Super excited that this is the last video for this worksheet. This was a long worksheet, y'all. So topic 8, we're going to look at applications, very specifically applications of linear inequalities in one variable, okay? So this kind of is going to be similar to applications with just linear equations, okay? You want to make sure you kind of have an understanding of the problem. What is it asking you? Sometimes you have to read a problem 2, 3, 4 times before you kind of get a feel for what's going on. So read it as many times as you need to have an understanding of what is happening in the problem. The hard part is typically translating the problem. This is that direct translation part where you convert the important parts to math. So you convert them to expressions or equations, or in this case, inequalities. Okay. You need to make sure you assign a variable. Okay. A lot of times we assign a variable to the thing we don't know. Or I don't want to say a lot of times, we always assign the variable to the thing we don't know. But in some cases, there's going to be more than one thing we don't know. And so we always assign the variable to the thing we know the least about. Okay. I do find that inequality problems, we don't go nearly as deep into them. So they tend to be pretty easy. The bulk of the difficulty is going to be with the linear equations in one variable and those word problems. Once you have your inequality set up, you want to solve it. Okay, perform the indicated operations, just take whatever steps are necessary to solve. I always say here the estimation can be used. I don't mean it as literally as some people take it. I just mean like sometimes you have to think, does my answer make sense? Okay. And you can sort of sometimes get an idea like in a minute, we're going to talk about test scores. If you have an answer that's 5,276, that doesn't make a lick of sense, right? So a lot of times if you just kind of think about it, use your skills with estimation, just have general number sense, you can tell if an answer is off sometimes, okay? And then always interpret the results. Just because you have solved the inequality does not necessarily mean you have answered the question. So make sure you answer the question fully, okay? So for example 8, it says solve each problem, include units with final answers. The first question is kind of like a classic inequality word problem. Okay. It says to earn a C in a course, you must have a final average of at least 70. So when you're in math classes, if you see at least or at most, it's screaming inequality. At least means your score can be 70 or anything bigger. At most means your score could be 70 at the highest, but anything less than that. So at most and at least are just, those are words that just indicate inequalities, okay? So again, to earn a C in a course, you must have a final average of at least 70, so 70 or more. On the first 3 exams, you scored 60, 75, and 62. The final exam counts as 2 grades. What must you get on the final to earn a C in the course? Okay. Well, the first thing we want to do is assign a variable. And what we don't know here is the final exam score. So this is kind of like I don't want to say a standard college class, but there are a lot of college classes where you have like 3 tests and a final, and that's your entire grade. So that's kind of sounding like the scenario here. So we know our 3 test scores. What we don't know is our final exam score. So we're going to let X equal the final exam score. And then you also have to remember how to calculate an average. So if you're averaging a set of numbers, you add them up and then you divide by how many like items you have. So if we have 5 test scores, we would add our 5 test scores and then we would divide by 5 and that gives us an average. Okay. So we're going to kind of mimic that here. So our first test score was a 60. Then we had a 75. Then we had a 62, so we would add those 3 test scores, but we also have to add in the final. But what's really important here is that the final exam counts, it should say as 2 test grades. Okay? So when we go to add in the final, we don't want to just add in a single X, we want to add in 2X because the final exam counts twice. And then that would give me 1, 2, 3, 4, 5 test scores. So even though you only see 4 items in the list, remember that final exam is really X plus X. So that's your 5 scores. So we want to divide by 5. And then this has to be at least 70. So that means this has to be greater than or equal to 70. Okay? So what in the world would we do to solve? I think for me, the first thing I want to do is get rid of the fraction. So if I want to get rid of the fraction, I can multiply both sides of an inequality or an equation by the LCD. Well, in this case, we only have one denominator, so that is the LCD. So I'm going to multiply both sides of this inequality by 5. Okay? Well, what ends up happening on the left, the 5 in the denominator divides into the LCD of 5 one time, and that 1 just gets multiplied by the numerator, so we're just kind of left with the numerator. So we would end up getting 1 times 60 plus 75 plus 62 plus 2x. And then that has to be greater than or equal to 70 times 5 now. So 70 times 5, you can just multiply the 7 and the 5 and then tack on a 0. So we would get that this all has to have a sum of greater than or equal to 350. Okay? So what I want to do now is just combine like terms on the left. And on the left, I have 3 constants. I want at most 1 constant. So let's see. If you don't have a calculator, get one out. We would take 60 plus 75 plus 62. So I have 197 plus my 2x, and that has to be greater than or equal to 350. All right. We now want to isolate the term that contains the x. So we want to isolate 2x, and the issue is this plus 197. So I want to subtract 197 from both sides. Well, 197 minus itself is just 0. 0 plus 2x is 2x. And then that is greater than or equal to 350 minus 197, which is 153. And then finally, we want to undo the multiplication of 2 and x. So I divide both sides by 2. And 153 divided by 2 is 76.5. So 2 divided by 2 is 1. 1 times x is x. And x has to be greater than or equal to 76.5. So if I were going to write my final answer, you do want to always include units and like a brief description. So I would put, how is it worded? To earn a seat, U. Okay, so I would put you must score 76.5% or higher to earn a C in the class. And that's the kind of answer I'm looking for. I'm not looking for a novel. I'm not looking for a big, long, like deep, meaningful, paragraph long description. I'm just looking for like a quick description of the answer. Okay. So that is how you solve those problems. That's a very typical linear inequality type problem. All right. Last up, we have a car. Let me move this little picture on my screen. A car can be rented from a rental company for $60 per week plus 50 cents per mile driven. How many miles can you travel if you can spend at most $600 for the week? If you ever see at most, that means the highest you could possibly spend is $600, not a penny over. So you could spend less than not $60, 600. You could spend less than $600. You could spend exactly $600, but you cannot spend more than $600. Okay? So what we want to do is kind of just come up with a generic formula or an inequality that could represent the cost here. Okay, so we know that we have a flat fee for the week of $60. We also know that we're going to get charged 50 cents per mile, and that per mile is that unknown piece, okay? And we as mathematicians assign the variable to the unknown. So we're going to let x equal miles driven. So as part of my fee, I have that flat $60 fee, but I am also getting charged 50 cents per mile driven, so 56x, okay? And all of this has to be less than or equal to 600. It can't be greater than or equal. If we go over 600, we've blown our budget to bits. We want to be less than or equal to 600. And if we can solve for x, that'll tell us how many miles we could drive, okay? So I want to isolate the term that contains the x, so I want to isolate 0.5x. To do that, I need to subtract 60. Well, on the left, 60 minus itself is 0. That leaves me with 0.5x is less than or equal to 3. Don't put a 3, bless my heart. Is less than or equal to 540. And then we want to isolate the variable itself, so we need to undo the multiplication of x and 0.5. So we're going to divide both sides by positive 0.5. Well, 0.5 divided by itself is 1. 1 times x is x. And that is going to be less than or equal to, if you still haven't gotten your calculator out, what are you waiting for? 540 divided by 0.5, and we get 10, I was about to say 10,080. Y'all, it is late. It's 1,080. So x has to be less than or equal to 1,080 miles. So if I were going to describe my answer, I would say to stay in budget, we can drive less than or equal. That's kind of awkward. We can drive, I'm going to say at most, that would be a better way to say this. We can drive at most 1,080 miles. So we could drive less than 1,080. We could drive exactly 1,080. But if we even drive half a mile over, we've blown our budget. So this would be my final answer. Okay, so that is linear inequalities in one variable. I think they're fairly forgiving. They're not the hardest thing ever. Luckily, if you can do all the stuff with equations, the inequalities aren't really that bad. Word problems aren't bad. The three-party inequalities aren't bad. I would say just be really careful with that division by a negative. That's probably the thing you got to be the most careful with. Okay. Um, Genuinely apologize for my dog. I try to make these videos in the evening because she's usually more settled. She's very playful, very active, very vocal. So earlier in the day, she's usually like really hyped up and wound and wanting to play. So in the evening, she usually goes to my bedroom and settles, but tonight was not it. I don't know what is out there, but she was mad. So I appreciate you all if you made it this far. Thank you so much. You're the best. Be wonderful, and I'll see you in